Alrighty, in this video we're going to be working with ratios. I'm going to give you a few different types of questions and how you can approach them. But first we need to understand what a ratio is and why we use them. So I've just got here an informal definition, but a definition nonetheless. A ratio is a relationship between related quantities. Okay, so it doesn't have to be the exact same thing. It could be boys to girls, it could be hours to minutes, it could be liters to liters, so it could be the same. And we're going to look at those sorts of things. And it's expressed in this way, and it's quantity 1, and this is a colon, but it's read as 2. So quantity 1 to quantity 2. Not TWO, but this to this, okay? So first type of question is to write each comparison as a ratio. Now, in order for us to actually write it as a proper ratio, we should, even though they can be between two different units, should be really in the same units. So I'm going to take the weeks and turn it into days. The reason why I'm taking the weeks and turning them into days is, rather than the other way around, because if I put 13 days in weeks, it's not quite 2 weeks, it's 1 and a bit, and we get a decimal, which is gross. So we'd rather have whole numbers. So in days, I'm going to have 13 to whatever 3 weeks is in days. Well, each week has 7 days, so 7, 14, 21. 21 days in 3 weeks. So the ratio from 13 days to 3 weeks is 13 to 21. The second question, when we're writing each comparison as a ratio, is 38 minutes to 2 hours and 11 minutes. So again, I'm going to take the bigger unit of time and convert it to the smaller one so I don't have a decimal. So this 38 is going to stay, the 38 minutes, and I need to turn this hours and minutes into just minutes. So dealing with the hours, 2 hours, well, each hour is 60 minutes, so 2 of them must be 120 minutes, but I've also got this 11, so I'm going to add it on. So 120 plus 11 is 131. And so my ratio ends up being 38 to 131. The second type of question that you might face is to not express something as a ratio, but rather take a ratio and simplify it so it's in its most simple form. So in this question, part A, I have 22 to 55. What I notice immediately is that the numbers are doubled, which usually, if they're 2-digit numbers, is indicative that they are divisible by 11. And it's true that these are both divisible by 11. So what I'm going to do to simplify is I'm going to divide by the same number, which in this case 11, but on both sides. And that's super key. You can't just divide one side. So if I divide 22 by 11, I get 2. Do my colon, because it's a ratio. 55 divided by 11 is 5. And there is no more common factor between those two numbers, so it's fully simplified. Make sure when you do these that you show what number you've divided by to get full marks, and just to communicate your mathematics to whoever's trying to interpret it. This second question has decimals in it, and we don't like decimals in ratios. It makes it more complicated than it needs to be. As humans, we really like whole numbers. So what I'm going to do before simplifying is turn both of these into whole numbers. And the easiest way to do that is recognize that they both have 1 decimal place. So if I multiply both sides by 10, it will just move the decimal place over and I'll get 2 whole numbers. So step 1 is multiply by 10. Notice we're not dividing this time because I'm going to temporarily make these numbers bigger. So 3.6 when I multiply by 10 turns into 36, and 7.8 will turn into 78. So in a way, even though these numbers are bigger, we have actually simplified because we no longer have a decimal, which is a bit confusing. We have 2 whole numbers, but then we can simplify those. Now they're both even, so they're definitely divisible by 2. That's the definition of an even number. They might be divisible by 4 or by 6 or something like that, but I'm not going to waste time trying to do all of the possibilities. I'm just going to start by halving them both. So I'm going to go, first of all, divide by 2, and see what I get. So 36 cut in half is 18, and 78 cut in half, well, if I just jump up to 80 briefly, 80 cut in half is 40, so this must be 1 less than that, so it must be 39. But of course, if you have a calculator and you struggle with that mental arithmetic, feel free to just use a calculator. And 39, not quite prime, but its only factor as far as I know is 13 times 3. But 13 doesn't go into 18. 3 actually does go into 18. Now that I think about it, it goes in 6 times. So I'm going to be able to divide both of these guys by 3. So hopefully I don't run out of room on my board here. Divide 3, divide by 3. And I'm going to get 18 divided by 3 is going to be 6. 39 divided by 3 is 13. And now 13 is a prime number, and 6 can't go into it because it's prime, so that is our most simple form. So notice that if I took these original ones and just divided by 6, I would have got this ratio straight away. However, I didn't notice that they were both divisible by 6, so I simplified matters. I said, they're both even, let's just try and divide by a half. We did, and then I just looked for a few more factors. 3 happened to be in both, so I divided by 3, and then I get a prime number in my final ratio, which means it's probably fully simplified. And finally for this video, we're going to be looking at a bit of problem solving using ratios. This question is determine the unknown value in each expression. So in this, or equation I probably should say, because there is an equals. In this first equation, a is unknown. In this one, x is unknown. I'm going to show you both ways to solve. So in equation 1, or equation A, I have 5 to 9, that is full knowledge of this first ratio, is apparently equivalent to 25 to A. Okay, and the way you figure out what A is you think about the known bits. So I know on the left of this ratio was 5, and I know this one's 25. So I think to myself, in terms of multiplication or division, what's happened here? So I think to myself, well, what did I have to do to turn 5 into 25? If you're good at your arithmetic and your multiplication tables, you'll know that it's been multiplied by 5, and hence this number, to keep them equal or equivalent, must also have been multiplied by 5. So I get 9 times 5 is A, and therefore A must be equal to 9 5s, which is 45. That's solved for A. Now we use a very similar bit of logic for this one, except we're probably going to be working backwards here. So I noticed that my right-hand side is full information, and the right-hand side of this ratio is known. So I asked myself, well, what happened here? How did I get from 24 to 4? Well, what I've had to do is divide by 6 to go that direction, divide by 6, and hence I also need to divide by 6 if I want to get back to x. So x is going to be 42 divided by 6, which is my favorite multiplication. X is equal to 7. So in summary, we've looked at expressing situations as ratios. We've looked at simplifying ratios, and now we've looked at doing a bit of problem solving to determine unknown quantities using ratios. I hope those 3 things help you in your maths.